Okay, so now talking about the assignments for Module 5, for the first section, Lesson 1, we are going to talk about, in number 1, treating breast cancer. It goes through a scenario where it gives you 2 different options for treatment that are now going to be tested, and it asks you what the explanatory and response are. In this one, the explanatory is going to be the treatment type. So they gave 2 different options, remove only the lump, or removal and radiation was the other treatment. So those are the explanatory. The response is what they're going to measure. So response is always what is being measured. And in this one, they're going to measure how long they live after the treatment. It asks then, what are the, or are they categorical or quantitative? Well, the first one would be categorical because you're talking about treatment type. So you have remove only and remove in radiation. So that's categorical information. The second one, the response, is going to be quantitative because it is the length of time or length of life in this case. So that is going to be measured with a number. So quantitative data. In number 2, they give you a graph of a scatter plot, and it is specifically IQ score and GPA. It asks in part A, does the plot show a positive or negative association between the variables? And then why does that make sense? So in this one, if I had to draw a line that I think might describe the data best, I probably would be right in here somewhere. Well, that definitely is trending upwards. So what I would say for A is that it has a positive association. It has a positive association. It does make sense because in the way that we always read these graphs is as you increase whatever's on the x-axis. So in here, as I increase my IQ, that means that my GPA is increasing as well. Okay, so that's how we would read that one. As I increase IQ, then that would mean my GPA would be increasing. In B, it says, what is the form of the relationship? Is it very strong? Well, I would call this like a moderate or moderately strong positive linear association. So we always name it by 3 things. So I'm going to start doing that right off the bat. Moderately strong, positive, linear association. It definitely could be stronger. It's not super strong, and we're going to talk about the strength of a relationship tomorrow. But this one right here is what I would call moderately strong. Next one says C. At the bottom of the plot are several points that we might call outliers. One student in particular has a very low GPA despite having an average IQ score. What is the approximate value of that person? They're talking about this one right here. This one right here is definitely going to be what I would look at as an outlier or atypical. They have a relatively an average, I guess, IQ, right, kind of in the middle. They have an average IQ, but a super low GPA. This GPA is also not the way that we do GPAs because we obviously don't have a 12-point GPA. This right here is a different kind of GPA. So this would not be typical for us. We would only have 1 through 4. So that kind of threw me off for a minute. But this one right here has a approximate value of, if this is 100, that would be 105. So I put 103. That looks to be about 103 for me, and probably like a 0.3-ish. Okay, and under 1 for sure. So that's what I put for that one. And that was obviously the value that they were looking at. Moving on to number 3. So this one is a graph with temperature versus the gas consumed in cubic feet for heating her home. So she's talking about heating her home. So immediately I'm kind of thinking to myself, well, that means as I increase the temperature of the month, right? As I increase the temperature in Fahrenheit that month, then I'm going to be decreasing the gas consumption, which completely makes sense. So when I have a negative association, it means that as I increase this one decreases. So as I increase the temperature of the day, my gas consumption goes down. If any of you guys know about electric bills, gas consumption in the winter is going to be higher because that's what your heater operates on. So cooler temperatures are going to be more gas consumed. During the summer, I hardly have any gas bill at all. That's when the electric bill goes up because of the air conditioner. But gas, I hardly use any gas at all because I don't need to turn on my heater. So that's what we see going on here. Understanding that is important for the next few questions, and then they'll go pretty fast. Does the plot show a positive or negative association? Definitely a negative association. And it says, does that make sense? And yes, it does. As the temperature increases, the gas consumed decreases. In B, it says, what is the form of the relationship? Is it very strong? That's when you're asking about the association. So in this one, it's very strong, negative, linear. Those are the three words when I ask you to define it. So very strong, negative, linear association. And it explains why. The points are very close to a straight line in this one. I could pretty much sum them up if I did a straight line here. They'd be very, very close. So that means that they are strong. That's how we determine strength. In C, it says explain what the point at the bottom right of the plot represents. Bottom right is this guy right here. Explain what that point represents. So I looked at it, it looks to be, to me, about 57. If it was 57 degrees outside, the amount of gas consumed would be somewhere like in the middle here, like maybe 300 cubic feet. So that's what that point means. If it is like 57 degrees outside or so, okay, 57 degrees, then it means that there's only, and I could even go lower here, maybe 250 or 300 cubic feet of gas used. Okay, number 4. In this one, it says here, basically to look at this is talking about lean body mass and then the metabolic rate. So as your lean body mass increases, it looks like the metabolic rate also increases. So as the lean body mass increases, then we have the metabolic rate also going up. You'll notice a difference in the shapes of the graphs here is because we have males being the red and females are the purple dots here. Does the same overall pattern hold for both women and men? Okay. Yes, they both have a positive association, but then they ask you to kind of talk about the differences between them. It's clearly in the spread of them. It seems like females follow a more typical pattern or a straight line, a stronger association, and then males have a weaker, more spread out association. In number 5, the last one, it asks you to actually make a scatter plot. So that's what I did here. I went through and I made a scatter plot of the data. This took a little bit of time. I had to figure out how I was going to label them, but I'll tell you that this definitely is what causes this. So the first thing when we make scatter plots, we want to make sure that we identify the explanatory and the response and make sure you have them correct. Every once in a while, it won't be that they're in the right order. But here, definitely body weight should have a response of backpack weight. Okay, so body weight should have the response of backpack weight. The smaller I'm at least expecting going into the problem, the less that somebody weighs, more than likely their backpack weight is also going to be less for various reasons, whether it's they decide to ditch more books or because they are younger. Like maybe we're looking at a younger person here. Okay, so this right here is that scatter plot, and I would expect to see something similar to that on your homework. Okay, that's all for this one, and good luck with the rest of your work.